In this video, we talk about CPU performances. We define what CPU performances are and we see the basic performance equation, which we apply to a specific case taken from Scott's CPU. First of all, we have to define performances. When you say that a computer has better performances than another, what do you mean? For example, we can take an analogy with the transportation field. If we have to take 1,000 people from Rome to Milan, which distance is 600 kilometers, and we take a bus with 100 seats going at 100 kilometers per hour, we have to do 10 journeys to take all the people to Milan. The total time we need to take all the people is 6 hours for the one way, plus other 6 hours for the comeback, times 10 trips equal 120 hours. But if we have a bigger bus with 200 seats going at 90 km per hour, we take 6.7 hours to go to Milan plus other 6.7 hours for the comeback. Then we have to multiply for 5 this time because we have 200 seats and the total time is 67 hours to take all the people to Milan. In this example, we see two different metrics. One is the time taken by the journey, or how fast we go from Rome to Milan. The first bus 100 km per hour and the second 90 km per hour. And the other is how fast we take all the people to Milan. The first bus takes 120 hours and the second 67 hours. If we now think about computer, we can recognize these two kinds of performances. We can measure the time needed to accomplish a task or the time needed to accomplish a lot of tasks. We call the first time execution time or response time, but in some application we want to measure the amount of jobs done in a given time. For example, in servers we prefer the second metric. We can improve the second metric without improving the first, just acting on the throughput, so on the amount of data processed. Although throughput is very important to improve general performance of a computer, we recall bus management pipeline, we focus on the execution time. So, time is the measure of computer performance. The computer that executes the same task in less time, measured in seconds, is the fastest. But in computer, resources are shared, so a CPU can work to accomplish a task or running other programs, accessing the RAM or waiting the I/O system. So the elapsed time experienced by the user includes all these things. Operating system manages the CPU parallelizing all the tasks, and this time can be improved, improving the throughput. But if we want to focus only on the CPU, we have to measure the CPU time, so only the time spent computing a specific task. A specific task normally is a program. As we know, the program is translated by the compiler and the assembler in a sequence of instructions, and the CPU essentially executes these instructions. So the first factor of our CPU time equation is the number of instructions. The second factor is the time needed to execute an instruction, but we know that time in computer is measured in clock cycle. So the second factor is the clock cycle per instruction, which is the number of clock cycles we need to execute an instruction. And the third factor is the clock period, so how long is the clock in seconds, which is, by the way, the inverse of the clock rate. So the CPU time can be explicited multiplying the number of instructions times the clock cycle per instruction, divided by the clock rate. This is a time expressed in seconds, which defines precisely the CPU performance. Lower the time, better the performance. So you see the clock rate is just one factor. With other factor fixed, higher the clock rate, lower the time, and better the CPU performance. Let's see an example with Scott's CPU. We take, for example, this piece of program. We want to calculate the CPU time. First, we translate the high-level code into low-level language, and then into machine language, as a compiler and assembler would do, getting these instructions. So the CPU task is executing 12 instructions. The second factor is the CPI, or clock cycle per instruction. Here we remember that in Scott's CPU we have a stepper giving the pace to all the control unit on the CPU. The stepper has essentially 6 steps, in which only one instruction is executed. Because the first 3 steps fetch the instruction register and increment the instruction address register, and the second 3 steps decode and execute the instruction. So our CPI is 6. Scott's CPU is a basic 8-bit CPU perfect for educational purpose, so it takes 6 clock cycles for executing one instruction. Modern CPUs, in average, take less than 1 cycle for executing one instruction, so we can talk about instruction per cycle, or IPC, and not CPI. The third factor is the clock rate. The clock in the Scott CPU gives the time lapse of the step. It is the time in which we move data from and to the bus. We imagine, for example, to have a clock of 100 MHz, so a clock period of 10 picoseconds. So in our case, the CPU time is 720 picoseconds. This is the way in which we compare CPU's performances. But actually it is not so easy, because as we said, CPU is normally managed by the operating system in order to compute several tasks. So in a moment it computes a task, in another task, then it accesses the RAM, etc. And isolating the CPU time is not so easy. Looking at this formula, we can understand what affects CPU performances. For example, using an algorithm or another affects the instruction count and even the CPI, because different instructions need different clock cycles. Using a compiler or another affects the instruction count and the CPI, because the compiler has to choose the basic set of instructions translating the high-level language, and it can be done in different ways and with different instructions. Programming language affect instruction count and the CPI as well, because statements have to be translated in instructions. Instruction set architecture affects all 3 factors of the CPU time equation, since it affects the instruction needed for a function, the costing cycle for each instruction, and the overall clock rate of the processor. Please leave me a comment and let me know if you liked this video. Make sure you put a thumb up, click the notification bell and subscribe to my channel.